This videotape shows the capabilities of the embedded button system, an architecture for embedding active elements in documents. Embedded buttons is being developed by the Interactive Documents Project in the Electronic Documents Laboratory at Xerox PARC. This videotape illustrates the group's progress after 6 weeks of active development. Embedded buttons serves two major functions. First, it connects editors, which lay out buttons and displays their feedback, to button classes, which determine how the button will respond to the user input and when feedback is necessary. Second, it delivers input events to applications that perform the action for which the button is a trigger. This document is managed by the Tioga text editor. Some of its text has been made into buttons. For instance, this phrase is a pop-up button. Clicking over it causes a menu of options to appear. This second button has a larger menu of options. Notice that the cursor changes shape to indicate the presence of a button. The next button is a two-state button, like those used in many control panels. When I click down on this button, it changes to italics. When I release, the button's internal state changes and a Tioga macro is executed to make the button's appearance reflect its new state. This button can have three states. It indicates its current state by changing its typeface and size from plain to bold to large. The last three buttons, called radio buttons, have related on-off values. Only one button can be on at a time. Notice that these button objects really are normal Tioga text. If we disable button activity for the document, we can change the appearance of this text or rearrange the buttons. With activity on again, we can test the new interface. Because this is just a regular Tioga document, we can use level clipping to find buttons. It is even possible to find buttons using textual search. In this picture, we have applied button properties to some objects in the Gargoyle illustration system. Clicking in the star causes a pop-up menu to appear. The yin-yang picture makes an unusual two-state button. This Gargoyle object uses three different interior colors to display its internal state. And the arrows in this figure are a group of radio buttons.
This Tioga document contains a number of pop-up buttons that send action requests to an application called the Buttonizer. The Buttonizer adds button properties to selected Tioga or Gargoyle objects. Thus we can use these buttons to make other buttons. For instance, this first button makes a selected piece of text into a pop-up button. This works for Gargoyle objects well. With the Make Stuffer Buttonizer, I can make a button that inserts its own contents at the current Tioga insertion point. This one makes a two-state button that shows its state with a change of typeface. And this makes a two-state button that video reverses itself when it is on. This button makes Gargoyle two-state buttons that show their state by changing their fill color. With this, we can make a button that has three states: plain, bold, or small. And with this Buttonizer, we can make a group of buttons that works together. After we click each button once to initialize it, the group behaves like the buttons on a car radio. The Clear button removes button properties to remove activity from text and Gargoyle objects. Finally, we have a Buttonizer that makes new Buttonizers. Some of the buttons that are made with these Buttonizers will need to be customized. For instance, this pop-up menu is okay for demos, but isn't useful for any particular application. We can edit the menu's properties using Tioga's ability to display nodes as editable strings. If we expand this node, we see that the words selected text have no hidden properties, but the word becomes has button properties. The postfix property causes a box to be drawn around it. The button data property is a description of the menu that pops up when we click on the button. We can edit this description. I will change the first entry and delete the third one. Now I will collapse the node into its normal form and try out the new menu.
Once we can easily make customized buttons, we can create documents that are collections of buttons that perform related functions. For instance, here is a collection of 5 Tioga macros. The first button makes text bold. The second button adds a box around the selected characters. The Cedar Sort button sorts a directory clause or an imports list in a Cedar program. This button changes procedure definition syntax into procedure implementation syntax. And the last button adds a line to the header of an electronic mail message. As another example, this gargoyle picture acts as a pictorial collection of illustration macros. These lines, for instance, transfer their width to selected objects in this or any other gargoyle viewer. And these lines transfer their dash pattern and stroke end shape. Finally, the colored objects in this gargoyle picture are pop-up buttons. They can transfer their fill color or stroke color to selected gargoyle objects.
The viewer in the left column displays a simple application with a control panel at the top and a drawing area at the bottom. The control panel is an active gargoyle document. In its current state, the tool allows the user to draw a rectangle by clicking the left mouse button to place a first point and the right mouse button to place a second point. If the circle mode is selected instead, the tool draws circles with center and radius determined by the 2 mouse clicks. The application checks the state of its control panel to determine which sort of object to draw. The square and circle in the control panel are gargoyle radio buttons that show a dash pattern when the mouse goes down over them and use thick lines to show which option is selected. The user can also change the line thickness that will be used in the tool using this pop-up button. Selecting the first entry causes lines to be thinner. Selecting the last entry causes lines to be thicker. Finally, this is a pop-up button that erases the entire picture. In this demonstration, the control panel is both active and editable at the same time. Thus, if we are careful to begin editing operations away from the buttons, we can edit the control panel. For instance, I can select these 2 buttons, translate them, and scale them. The buttons continue to function. Embedded buttons can be used in an unconventional way to customize an application temporarily. Here we have an ordinary gargoyle picture made up of a set of circles. Perhaps we would like to make a pattern by changing some of these circles to black. We could do this using ordinary gargoyle operations. Another way, however, is to turn all of these objects into 2-state buttons that switch from black to white. Using the resulting buttons, we can turn circles black at the click of a button. If we don't like a color change, we can undo it by clicking again. Here we use this technique to experiment with pictures made out of overlapping circles. When we are done, we can clear the button properties from the objects, leaving us with a normal gargoyle picture. We could also restore normal behavior by turning off activity for the document. We can imagine many applications of interactive documents that are not yet implemented. In the near future, it should be possible to turn phone numbers into buttons in whatever document the phone number appears. Clicking on the button will dial the number. People will be able to solicit information by sending a form through the electronic mail. The returned documents can be tabulated automatically. Electronic mail messages describing new software will make that software available with the press of a button. Programs that produce lists of files now will produce lists of file name buttons instead. These buttons will make it easy to open the file, delete the file, and perform other operations.